I thought we. Oh.
Okay, here you go. You can keep on continuing your other page if you want to. What do you need? The what? Oh, it's all the same.
It's all the same.
It's all the same key. I was just saying, when you click the drop down from the list on Canvas, you're looking at the Google form, right?
Yeah.
When you click in the Google, the drop down, just make sure you get pear and apple and not apple and pear. Because both choices exist.
So like the sheet that you gave me is for all of
the yellow sheets, the key that I gave you, it all applies to one.
No, but you're
I mean, one applies to all. Something like that, right? Okay. Here you go. What's ocean acidification mean? The pH level goes down. Okay. Now, I don't know about you guys, but pH is a kind of a technical term. If we were to like explain this to I don't know, say you wanted to explain this to my kindergartner, what would you say? Acid level goes up. AKA, right? Acid level goes up. Why does the acid level go up? What's it caused by? What makes the acid levels go up? Yoo-hoo, I'm talking. What makes the acid levels go up?
More CO2.
More CO2. Hey, now, how much CO2 is in the air? How much? Somebody ask Siri real fast. How much CO2 is in the air? Who's got their Chromebook pulled up, or Siri real fast? Just ask Siri. What percent CO2 in the air? 412 parts per billion. What's that mean? Can you give us that in a percent?
0.04%.
Is that what you said? Is that the same thing? 47. It's not 47. 0. So air has, that's the percent I know, 0.04% CO2. Okay. That's a very small amount, right? What, by the way, what's most of air made out of? Oxygen. What else? Nitrogen is actually the biggest one. That's most of it. And then oxygen is the next biggest. So the actual amount of carbon dioxide in the air is very, very, very tiny. Very tiny. But it's important because it does change how it gets in the ocean, right? So ocean acidification, the pH level goes down, or you could say the acid level goes up. It's causing by more CO2. Sound good? How does that work? How does that work? Got an idea?
No, I think you were thinking AME on the
What?
on the top where TH is, there's no E.
You know what? It's
Like
oh, that's pretty funny. Good catch. There you go. Now you happy now?
Yes.
Good. All right. So, how does this work? CO2, look, here's the water. What should we use to draw CO2? A circle. CO2, okay? So if CO2 is here, where's it going to go? Down into the water. All right? So next what happens? How does that make the water more acid? Do we know?
Does it react with the
Somehow, so we got H2O down here, right? And somehow it like connects up with the CO2 somehow, right? And then when they add up together, they do some kind of magic, and then they turn into acid, right? Y'all good with that?
Yeah, always.
All right.
And then the oysters die.
And then the oysters die. Isn't that sad? All right. So next thing here. All right, so we talked about that already. I want to show you some pictures here. We did all that. All right, check this out. Check this out here. This says, I don't know if you can read this where you're sitting. This is Pacific oyster larvae, baby oysters, raised under more favorable ocean conditions in the top and under acidified conditions in the bottom. So this is day 1. This is when they're first born. There's these two right here. This is day 2, and then this is day 4. By the way, how big is, this says they're each less than 1 millimeter wide. How big is a millimeter? So on the ruler, the ones that are centimeters are the ones that are like about as wide as your finger. And then the millimeters are 1/10 of that. Your pencil lead, the pencil lead, like the thicker of the kinds of pencil lead, are 0.7 millimeters, so almost 1 millimeter. So these things are like about the width of a pencil lead.
That's not that much.
That's pretty little, isn't it? What do you think? What do you think here for these guys?
They're tiny.
They're tiny. What about the acid?
They look softer when they're growing in the acid.
Softer, you think?
Yeah.
Like they're getting
More
mushy and
goopy.
gross.
Yeah,
They look like an
damageable.
apple.
They do kind of look like an apple, like the pokey parts of an apple.
Yeah.
Yeah.
It's more easily damaged.
Why aren't they round?
Because it's eating it.
Something's happening, right?
It's dying. They're dying.
Something's going on. Okay.
We just learned about I have pencil